Hello, hello, hello everyone. Today we shall discuss about hello everyone. Today we shall discuss about a new chapter, and that is motion of system of particles and rigid bodies. Today we shall discuss motion of system of particles of rigid bodies. Right? We'll see how it goes. Today we'll discuss about motion of system of particles, right? That is motion of system of particles. Motion motion of system of particles, system of particles and a rigid body. We'll discuss this chapter, that is motion of system of particles and rigid body. First of all, we learn that the difference between two motion, one is translation and rotational motion. This is the main difference between translational motion and rotational motion, right? This is rectilinear motion. This is rectilinear motion. And this is rotational motion. We'll find the difference between rectilinear motion and rotational motion. First, the rectilinear motion, what we find, the first difference is that is rectilinear displacement. Rectilinear displacement. Rectilinear displacement. And in rotational motion, we will get angular displacement. Rectilinear displacement we represent it by x, and in angular displacement, angular displacement is represented by theta, right? And number two is velocity. Rectilinear, these are all rectilinear. Velocity. Velocity is defined as v is equal to dx dt. And in the case of rotational motion, angular velocity, angular velocity, angular velocity angular velocity angular velocity is defined as omega, and that is equal to d theta by dt. d theta by dt. You have to remember all these things. Number three is acceleration. A double Cbse expression can be defined as A is equal to dv dt by dt, or it can be represented as dx square x by dt square. In the case of rotational motion, number 3, we can write it as angular acceleration. Angular acceleration. Angular acceleration, that is alpha is equal to v square theta by dt square. This is, or it can be written as alpha is equal to d omega by dt, and that is equal to d square theta by dt square. Number 4 is m, or mass. Mass is represented as m. In case of rotational motion, mass is represented as I. I means moment of inertia, and I is the moment of inertia. Moment of inertia. Moment of inertia. That is equal to I. And in question of difference of phi is F, that is force. F is equal to m into A. But in the case of rotational motion, it will be torque. That is tau is equal to I into alpha. I is the moment of inertia and alpha is the angular acceleration. And number 6 is kinetic energy. Kinetic energy is going to know that half mv square, half mv square. But in case of angular kinetic energy, angular kinetic energy, it will be half. In case of m, it is I. In case of v, it is omega square, half I omega square. And number 7 is momentum. Momentum P is equal to m into v. It is rectilinear motion. And rotational motion, momentum can be written as angular momentum. Angular momentum. And that is equal to L is equal to I into omega. That is angular acceleration. Now, see, today we shall discuss about motion of system of particles and rigid body. In rectilinear motion, rectangular displacement is represented by x, and in rotational motion, angular displacement is represented by theta. Velocity is equal to dx by dt, and angular velocity is omega equal to d theta by dt. Expression is a is equal to dv dt, and it will represent d square x by dt square. But in case of rotational motion, angular acceleration alpha is equal to d square theta by dt square, or you can write d omega by dt. Mass is represented by m, but in case of rotational motion, it is moment of inertia or I. F equal to ma, but in case of Rotational motion it is tau, torque that is I into alpha. Kinetic energy is half mv square, but angular kinetic energy is half I omega square. Momentum P equal to mv, but in case of angular momentum, it is I omega. Right? This is the difference between rectilinear motion and rotational motion. Now we learn about the major things about center of mass. What is the center of mass and how it can be defined in center of mass? Let us find the uh, difference how we define the center of mass, right? Now we define the center of mass. Center of mass. Define this center of mass. Now, how to define the center of mass is very important for us, right? That is center of mass. Suppose we want to find there are various particles. What is the center of mass? If I take a whole body or suppose this is a coordinate Ox, Oy and Z coordinate. This is O, this is Y, this is Ox and this is Oz. If there are many particles, suppose there is a particle at a distance r1, this is m1 and the distance is r1, the position vector is r1. And in this case, there are many particles. Suppose there is another particle, there is m2, and the distance is r2, right? And we find the center of mass. Most probably here, center of mass Cm, and we take this resultant as r. Then the positional vector of the center of mass, this is center of mass, positional vector is r. R is defined as m into r, m into r vector is equal to m1 r1 vector plus m2 r2 vector plus m3 r3 vector plus in this way plus mn rn vector, mn rn vector. If we add all the vectors, then we will get capital M is equal to m1 plus m2 plus m3 plus mn, right? Therefore, we get the value of r vector of center of mass is equal to m1 r1 plus m2 r2 plus m3 r3 plus mn rn divided by capital M. Right? Now it can also be written as that vector r, position vector of center of mass, is equal to summation. This is what we call it is summation. Summation I varies from 1 to n. That is mi ri vector, mi ri vector divided by n. This is the position vector of center of mass of the rigid body, right? And this is the relation. And this is what we call first mass moment. It is called as the first mass moment. Right? Therefore, we can write that summation, that is summation mi ri vector I varies from 1 to n is equal to mi m into r vector, right? If we take two particles, take two particles, then r vector will be two particles m1 and m2, then it will be m1 r1 vector plus m2 r2 vector by m1 plus m2 for two particles. This is 4, 3. If the coordinates of the center of mass, if the coordinates, if the coordinates of center of mass, if the coordinates of center of mass x, y, z and the position vector and the position vector of two particles is x1, y1, z1 and x2, y2, z2, x2, y2, z2, then capital X will be equal to m1 x1 plus m2 x2 by m1 plus m2. This is the coordinates of the center of mass m1 plus m2, m1 plus m2, and y is equal to m1 y1 plus m2 y2 by m1 plus m2, and the third quadrant z is equal to m1 z1 plus m2 z2 by m1 plus m2. These are the coordinates of the center of mass of these two particles. In this way, we can find the center of mass of any particle, right? Then find the motion of center of mass and momentum conservation. We'll find this is defined as the center of mass in this way. That is mr. This will summation mi ri I varies from 1 to n is equal to mr. And this one is particularly the coordinates of the center of mass x, y, z and the position vector of two particles is m1 x1 y z1 and x2 y2 z2. The particles of this one m1 is suppose x1 y1 and z1, and the position vector of this m2 is x2 y2 y2 z2 z2. Then the center of mass, the position vector of center of mass is capital X y. In this way, you have to find the coordinates of the coordinates of the center of mass. Now we'll learn about motion of center of mass and momentum conservation. In the next phase, we'll learn about motion of center of mass and momentum conservation. Motion of motion of motion of motion of center of mass mass, and momentum conservation. And momentum conservation in a system of particles. In a system of particles. In a system of particles. A system of particles. Let 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 the mass or masses of the particles be m1, m2, m1, m2, m3 up to mn, and the velocity v and the velocity be v1, v2, v3 up to vn. Therefore, you now know that total momentum is equal to sum of momentum of all particles. So the total momentum vector is P is equal to, you can write P1 plus P2 plus P3 up to plus Pn. All you can write is P1 as m into P1 plus m into P2 plus m into P3 plus mn Vn. These are vectors, therefore we write it as vector. If the center of mass if the velocity if the velocity of the center of mass if the velocity of the center of mass is v, then we can write v is equal to m1 v1 plus m2 v2 plus m3 v3 plus mn vn divided by capital N. Where capital N is equal to m1 plus m2 plus m3 plus mn, sum of all the particles, that is capital M. Then what we get, that is v is equal to m1 v1 plus m2 v2 plus m3 v3 plus mn vn by capital N. With comparing this equation, the that is B. Suppose it is 1, and this is 1, equation is 1, and this is equation is 2. And if we compare this equation with equation 2, then we get that P is equal to capital M into V. So here P is equal to capital M into V. And here we get that the total momentum of the system of particles and is equal to the total mass and velocity of the center of mass. Velocity of the center of mass. Right? If we integrate both sides, what we get? If we differentiate both sides, then we are getting dp by dt. dp by dt is equal to m, since m is a constant, m dp by dt. Or you can write m is equal to a, where a is equal to acceleration of center of mass. Acceleration of center of mass. Center of mass. Acceleration of center of mass. But MA is equal to external force. Know it. Therefore, we can write that dp by dt is the net force, external force. Therefore, what we are getting, that is the rate of change of momentum is equal to external force. If net external force is equal to 0, then dp by dt is equal to 0. Or you can write, therefore, P is equal to constant. And here it is, we find the momentum is conserved. And we find that momentum is conserved. P is constant and P is momentum. P is momentum. Momentum is equal to constant. That means it is the conservation of momentum for system of particles or motion of central mass and momentum conservation. In this way, we can prove motion of central mass and momentum conservation. That is, momentum is equal to constant. Now we find this is the motion of central mass. This is number 1 is motion of system of particles of rigid bodies and the difference between rectilinear motion and rotational motion. And number 2, we got that motion of center of mass and momentum conservation. The momentum is equal to constant or conserved. Then find the Center of mass of rigid body. How to find the center of mass of rigid body that we are going to learn. The center of mass of rigid body. Center of mass of a rigid body. Rigid body. Center of mass of a rigid body. In case of center of mass of a rigid body, find x is equal to, we get the value integration of x dm by integration of dm, and we get the value as 1 by capital N integration of x dm. This is x, and the value of y will be 1 by n into integration of y dm, and the coordinates of z will be 1 by n integration of z dm. With this center of mass, we find the center of mass of the rigid body with this formula, that is x equal 1 by n x dm, y equal 1 by y dm, and z equal 1 by n z dm. Now we will find the center of mass of a uniform rod. Let's find the center of mass of a uniform rod. We'll find the center of mass of a uniform rod. Suppose this is a rod here. We've taken this part A to B, and this is dx,